Sir.
Okay, my screen is visible to all of you, right?
Yes, sir.
Okay. So in last session, we have discussed what decorator and bridge design pattern, right? Today I'm going to complete the remaining three design pattern, that is composite, proxy, and flyweight design pattern. Let us start the discussion from composite design pattern. It is one of the important design pattern that you need to understand, right? Let us first read the definitions, and then I will explain the definition with one example. So what is a composite design pattern according to Gang of Four definition, right? The composite design pattern states that compose objects into the tree structure to represent part whole hierarchies. Composite lets client treat individual object and composite objects uniformly. So what it means? It means the composite design pattern represents part whole hierarchies of objects. That means the client can access the individual object or composition of object, or you can say composite objects in a uniform manner. So in simple word, we can say that composite design pattern compose the object in the form of a tree structure to represent part as well as whole hierarchy. This design pattern is used when we need to treat a group of object in a similar way as a single object. So in simple word, what I can say that, right? So basically composite design pattern is used when we need to represent some kind of a tree structure. Some kind of a tree structure like this one. There should be some root node, then there some leaf node, intermediate root node is also there. So if you want to represent some kind of a data in this manner, right, then you need to use composite design pattern. And what is the main objective of this design pattern? That you can access the object part or a whole hierarchies. What it means? It means you can access this computer object, you can access this cabinet object, even you can access this CPU object in the same manner. So if this is not clear at the moment, let me explain this with one example so that you will understand. So before understanding this composite design pattern, so we need to understand, so what is this composite term means is. The term composite means a thing which is made of several parts or several elements. So let us understand the composite design pattern with one real-time example. Suppose you want to assemble a computer. And if you want to assemble a computer, means what? You need to integrate multiple electronics component all together to form a computer. For example, if you look at this diagram, then if you want to form a computer, you need a cabinet. Inside a cabinet, you need to put hard disks and motherboard. Inside motherboard, you need to put CPU and RAM. Similarly, peripherals is there, right? Some mouse pointer is there, some keyboard is there, additional the component which you can say. So that means if you want to build a computer, you need hard disk, CPU, RAM, mouse, keyboard, peripherals, motherboard, cabinet, and once you combine all these things, then you can say it's a computer, right? And here and in this diagram, whatever you see, everything is one object. Here you can consider computer is an object, cabinet is an object, hard disk is an object, motherboard is an object, CPU, RAM, mouse, keyboard, peripheral, whatever you see, everything is one object. Then from here we need to understand what is composite means. So composite means it is one object, or composite means it is one component which is having some child components, right? If a component having some child components, then we can say that component as composite component, right? And if a component which does not have any child component, then we can say that is a leaf component. And in our example, if you see computer, cabinet, motherboard, peripherals, these are the four components which we can say composite components. And guys, remember a composite component can contain another composite component also. So in this case, if you see, this is a computer. Computer is a composite component. It is containing two other components. And these two components, what you are seeing here, cabinet and peripherals, again they are composite component. Again, this cabinet, which is a composite component, it is containing some leaf node, right? And also it is containing some other composite components. And here you can say hard disk, CPU, RAM. they do not have any child element. Even mouse and keyboard, they do not have any child elements, right? And whenever a component does not have any child components, you can set that component as the leaf component. And whenever a component having any child component, that child component might be a composite component or might be a leaf component, right? Then you can set that component as a composite component. And according to composite design pattern, what it is saying, you can access in part whole hierarchies. What it means, or it is saying that composite lets client treat individual and composite objects in a uniform manner. What it means in our requirement, if we are developing one application where our requirement is to define some method in the composite components, as well as we need to define the same method in the leaf component, and if we want to access the method in a uniform manner, that means we can access the method on individual object, even we can access the same method on the composite component object, right? Then in that case we need to use composite design pattern. For example, right? So if you look at this diagram, right, then you can see which are the composite components and which are the leaf components. See, this is one composite component. Why? Because it is having some child element. This motherboard is also a composite component. Why? Because it is having some child component. This hard disk CPU RAM, they do not have any child component, so they are leaf object. Similarly, peripherals, it is a composite object because it is having two child, and here you can see these are leaf object because they do not have any child component. And computer, it is a composite object because it is having two more child components. See, so what is the requirement? The requirement is that, right? Suppose you want the price. Suppose you want to know the price. So you can ask the seller or shopkeeper man, right? Hey, what is the price of the RAM? You can also even ask what is the price of the CPU. If you are asking what is the price of RAM, then he will tell you the price of the RAM. And if you are asking only for the price of the CPU, then he is going to only tell you the price of the CPU. But if you are asking what is the price of the motherboard, right? That means suppose you are having one method called get price. You can apply that get price on the RAM object. You can also apply that get price method on the CPU object. When you are applying that method on the RAM object, on the leaf object, then it is going to give you only the price of that particular element. But if I'm asking what is the price of this motherboard component, that means as it is a component, it is having multiple child elements. In that case, what will happen? It will combine the result of the child components and then it will return the result. So in this case, if I'm asking the price of the motherboard, then it should display the price of the CPU as well as the price of the RAM. If I'm asking what is the price of the cabinet component, then it should display me the price of the hard disk as well as it should display me the price of the CPU and RAM. If I'm asking the price of the peripherals, means it should display me the price of the mouse and price of the keyboard. And if I'm asking the price of the computer, then it should display me all the price of all the component. That means we are going to define some method, right? That method is applicable to the leaf object as well as that method is also applicable to the composite object. And we are going to call those method in a uniform manner. Uniform manner means it doesn't matter whether the object what you are going to create is a leaf object or whether the object what you are going to create is a composite object. You can access that method in the same manner, right? So let us moving forward, let us go and implement this example. Let me create a project to the solution. I'm going to discuss a few examples so that you will get more clarity because it is one of the important design pattern, right? So let me create the I component, right? This is going to be the base component interface. And this component interface is going to provide the operations which are going to be common for both leaf and a child component, for leaf and a composite components, right? So in this case, you can see I'm creating one method, right? I'm creating one method called display price, and this method is going to be implemented by both you can say leaf object as well as you can say composite object, right? So then guys, give me 1 minute. So once we create the component interface, then we need to create two concrete classes. One concrete class is representing the leaf component, and another concrete class it is going to represent the composite component. Let me create a class file with the name leaf.cs. This is going to be our leaf component, right? Which leaf component means a component which does not have any child component, right? Let me copy the code, then I will explain you the code.
హే హాయ్ మౌనిక, నువ్వు అన్నావు కదా అడుగు నెగోషియేషన్ ఏమైనా చేస్తారేమో అనేసి ప్రాజెక్ట్.
So you can see this is the leaf component, and this leaf component having two properties. One is price and one is name. This price is this name is nothing but the name of the component. Like you can say in our example, it might be the name of the CPU, hard disks, right? A mouse, keyboard, and the price is nothing but it is the property which is going to tell you the price of that particular component, right? Right. So then you can see these two properties what I have declared here. I'm initializing using the class constructor, and this is the display price method which you can find inside the component interface. And this display price method is going to display the component name as well as the component price, right? And this display method is the common method which you can call using the leaf object. And again, you can also call that method using the composite component, right? Let me create a class file with the name composite.cs. Let me add the class composite.cs. Let me copy paste the code. But guys, remember, behind the scene, the composite component is not going to do the actual task, right? It is internally delegating the real work to the child component, right? So this composite component, if you know, this is a composite component, and composite component means this component having some child element, right? And that component, that composite component name, I'm going to store inside this name variable, right? And whenever I ask, right, if you know, if I'm asking for the price of the cabinet, then it should be show the price of the hard disk, CPU, and RAM. If I'm asking the price of the peripherals, it should show me the price of the mouse and the keyboard. That means this peripheral does not have itself does not have any price. It is going to combine the price of the child components, right? So in this for that particular reason, you can see inside this class, I'm only declaring this name. This name means it is the name of the component. And inside this peripheral class or inside this cabinet class, we are having multiple child components, right? Multiple child components. So that child component might be another composite component, no matter. So inside this component class, we are having multiple components. So for storing those multiple components or child components, I'm creating a reference variable of a list of a component type. This variable is going to hold the list of a child component, and this is nothing but the name of the component, right? So then what I'm doing, I'm using the class constructor, initializing this name. What is the component name that you are initializing, right? And this is the add method. Add method means if you want to add any child component inside a parent component, let's say this name, I'm giving the name as peripherals. Then inside this peripheral, you want to add two more leaf components. Those two more leaf components or composite component, no matter what it is, right? That you are going to add using this add component method. I will show you how you are going to create the leaf object, how you are going to create the composite object, how you are going to add a leaf component inside the composite object, how you are going to add composite object inside another composite. Everything I'm going to show you. But this method, what I'm declaring here, it is going to add both the leaf component as well as composite component inside a composite component, right? And this is the display price method. But if you remember, the actual price is going to be shown from the leaf object, right? That means what? Now, whenever the display price method is called, what I need to do, I need to first get the list of a child component of that parent component or of that composite components, and then we need to call the actual display price method, which is having this leaf object, right? So basically, if you are creating a component called peripherals, then inside this component, mouse and keyboard are there. Then what we need to do, we need to get each individual leaf object. And once you got the leaf object, then if you see in the leaf object class, there is a method called the display price, and that method what we are calling here. And that method is going to display the component name and the price name of a composite object, right? Then what we need to do, uh, then we need to use this leaf object and the composite objects in our client code. That means what? So point that you need to remember, you can access both this leaf object and both this composite object in a uniform manner. Uniform manner means you can create an instance of leaf object. You can call this display price method. In the same way, you can create an instance of this composite object, and you can also call this display price method. Whenever you create an instance of a leaf object and call this display price method, it is going to display only the price and name of that leaf object. But whenever you are creating an instance of a composite object and calling the display price method, it is going to display the price and name of all the components, right? All of leaf object which are under that composite object. And in our client code means the main method of our program class is going to be the client code. So from that client code, we are going to use both a leaf object and a composite object. That means I'm going to use I component. I component means the class that implements the I component interface. And in our example, it is the, which class it is? It is the composite class and the leaf class. Let us understand how we are going to create the leaf object, how we are going to create the composite object, how we are going to add leaf object under a composite object, how we are going to add a composite object under another composite object, and how we are going to call the display price method to show the price details of individual leaf object as well as you can say the composite object, right? So we need to create the object in this manner. So basically, we are going to create a hard disk, CPU, RAM, mouse, and keyboard. These five are going to be our leaf object. Let me first create. So for creating the leaf object, what is required? Two things is required. What are the things? First of all, the name of the leaf object, and the second one is the price of the leaf object, right? So I'm creating five leaf object. I'm giving the name as hard disk, RAM, CPU, mouse, and a keyboard. And while creating the object, you need to pass the name of the leaf object and the price. So I'm giving hard disk 2000 RAM, 3000 CPU, 2000 mouse, 2000 keyboard, and 2000, right? So leaf object is created. So now if you want, then you can call the hard disk dot display price method. So in that case, this display price method is going to be invoked, and here it will show you hard disk, and whatever the price you said, that is going to be displayed here, right? But at that I will show you. But before that, we need to create this one, right? Once you have this five object, now tell me, inside motherboard, which components we need to add? Inside motherboard, we need to add CPU and RAM. That, and inside peripherals, what we need to add? Mouse and keyboard. Inside cabinet, what we need to add? Hard disk and motherboard. Inside computer, what we need to add? We need to add cabinet and peripheral. That means how many composite objects are there? 1, 2, 3, and 4. Let me create 4 composite objects. You can see this is motherboard. And while creating the composite objects, right, what we need to pass? We need to pass only the name of the object, right? So here the name of the composite object is motherboard, cabinet, peripherals, and the computer. So as per our requirement, we need to create 4 composite objects, and that 4 we have created, right? So once you create the composite object, then what we need to do? We need to add the child components, right? And inside motherboard, how many leaf objects are there? CPU and RAM, right? So inside motherboard, we need to add CPU and RAM. Inside cabinet, we need to add hard disk and motherboard. Inside peripherals, we need to add mouse and a keyboard. And inside computer, we need to add cabinet and a peripheral. So first of all, let me show you inside the composite component class, there is a method called add component, which is expecting a type of I component. I component means what? A class that should implement the I component interface. And in this case, does this list class implement the I component interface? Yes, it is implement. That means you can pass the leaf object as a parameter to this add component method. And further, if you see this component class, it is also implementing the I component interface. That means you can pass this composite instance or this leaf instance as a parameter to this add component method, right? So now what is our requirement? Now we need to add CPU and RAM. CPU and RAM means these are leaf objects. So you have to pass the CPU and you have to pass the RAM leaf object as a parameter to the add component method using the motherboard instance, right? So we have created the motherboard component. Inside this motherboard component, I'm going to add two child component. One child component is CPU. This is a leaf object, you can see. Another child component is RAM, and you can see this RAM is also a leaf object. So I'm adding two components inside the motherboard component. What are the component? RAM and a CPU. You can see inside motherboard, I'm adding RAM and a CPU. That is done. Next, what? Then we need to add a cabinet. We need to add child components under the cabinet. Under the cabinet, what are the child components? One is hard disk and another one is motherboard. So you can see cabinet dot add component. I'm providing motherboard, and add component, I'm providing the hard disk. And here, if you remember, this hard disk, it is a leaf object. But the second one, this motherboard, it's not a leaf object, it's a composite object. And as per our requirement, this hard disk is going to be a leaf object, and this motherboard, it is going to be a composite object. So inside one component object, you can have another composite object, or you can also have only leaf object. As you can see, motherboard, it's a composite object also, but it is having only leaf object, right? So once we have created this, next we need to add the component under the peripherals. If you look at the peripherals, inside the peripheral composite object, we need to add mouse and keyboard leaf object, right? And here you can see peripherals dot add component mouse, peripherals dot add component keyboard. So we have added mouse and a keyboard. And once you have created this, then you need to create the you need to add the child component under the computer composite component. Inside the computer, we need to add cabinet and a peripheral. So you can see computer, I'm adding cabinet, and inside computer, I'm adding peripheral. So we have ready with our tree structure. So once you have ready the tree structure, once you created the virtual hierarchy of the object, then you need to access the you can access those objects in a uniform manner. Uniform manner means the same method I can apply on this leaf object, and the same method I can also apply on this composite object. Let me show you. So now I want to show the price of a computer composite object. Then what we need to do? I need to call this display price method on the computer object. You want to know the price of the child or leaf component, right? So you want to know the price of the keyboard child or leaf component. Then you need to call the display price method on the keyboard. So here, if you remember, computer, it is a composite object, and keyboard, it is a leaf object, right? Now you want to know the price of the composite cabinet. Cabinet means it should display the price of a hard disk, as well as it should display the price of the motherboard. As part of motherboard, it should display the price of the CPU and RAM. So if I'm asking for cabinet, then it should display me the price of these three leaf object, right? So here I'm showing the price of the cabinet, right? So let me run the application and show you the output, whether what we are expecting we are getting or not. So inside computer means all components price and name should be displayed. When I'm asking the keyboard means it should only display me the price of the keyboard. And when I'm asking for the composite cabinet component, it should display me the price of hard disk, CPU, and RAM. See, inside the computer, all the 5 component price and what you can say name is displayed. Yes. Inside keyboard, only keyboard name and price, because it's a leaf object. And inside cabinet means you can see it is saying CPU, RAM, as well as hard disk. So that means what? Now, whatever objects we created, we can access them as part or as a whole. Part means you can individually access that. Whole means you can access as a whole. Whole means whatever the child, everything will be accessible by the object. Now, in this case, you can see computer means all the components. Keyboard means only keyboard. Cabinet means CPU, RAM, and hard disk. Clear, guys?
Clear.
Okay. So once you understand this, now we need to understand the UML or class diagram of this design part, right? So already we have discussed, you have one component interface, and in our example, it is the I component interface, which is going to provide the common operations, which are going to be implemented by both leaf object and a composite object. See, leaf object inheriting this I component, composite object is also inheriting this I object. Client using the component means what? Now client is going to use the classes which implements the I component interface. And in this case, both leaf and composite classes implementing this IE component interface. You can see in the client code, we are creating instance of a leaf as well as we are creating instance of a composite because both are implementing the I component interface, right? And then inside the composite class, we can add children I component inter components, right? If you see the composite class, then we are having some components variable, and using this add component method, we are adding child component of that I component type, right? And this is what it is showing. And the client is going to use this leaf and the composite both classes. It is going to clear, guys.
Yes. Yes.
Okay. So when we need to use composite design, but means when we want to represent part whole hierarchies. Part whole hierarchy means we want to access the object as a part, or as well as we can access the object as a whole, right? Individually you can access, composite you can also access. We want the clients to ignore the difference between composition of objects and individual object. That means whenever you want to make sure the client should not see any differences between accessing the individual object and the composition of objects, then you need to use composite design pattern. So let me show you a few more examples of a composite design patterns so that you will get more idea, right? So suppose now I'm going to show you another example of composite design pattern, right? So suppose in your system there is some root, there is a file folder structure directory. Any computer you can consider, right? There is some file, there is some folder and file structure. Let's assume that this is my root directory. Inside this root directory, I'm having this folder 1 and folder 2. Inside this folder 1, I'm having subfolder 1, and inside this subfolder 1, I'm having this MP3 file and this my resume PDF, right? And inside folder 1, I'm having this text file as well as video file, right? That means this is a component, this is a composite component, this composite component containing another composite object as well as a leaf object. So here, this my book.txt, my video.txt, these are leaf object. This subfolder, it's a composite object. Inside this composite object, I'm having two more leaf objects. And this is another folder. This folder contains some exe file and some documentation file. In this case, these leaf files are nothing but your leaf objects. This my software.exe and doc, it is nothing but your leaf object. And this folder, it is nothing but your composite object. Now, what is our requirement? So this kind of things you are storing in your machine, right? Now, what is my requirement? I want to get the size of the file as well as folder. So what it means if I want to know the size in KB, so here by default, whenever you store any data in the any file in your machine, it is going to be stored in the form of bytes, right? And for example, if you can see this is one document, right? If you go and check the details, right? So you can see it is showing in this byte format, right? So 1.02.268 bytes. So what is my requirement? Now, when I want to return the file size, but in KB format, if I am asking, I want to know the size of the file, my music.mp3 in KB, then this object should return me the, this lib object should return me the file size in KB format. And what is my requirement? I can access the individual objects, the individual lib objects file size, as well as I also have the ability, or my application should have that flexibility. It should allow me to access the file size based on the folder also. If I'm asking subfolder 1 file size, then it should sum the file size of these two files and return me the sum as a result. If I'm asking the file size of this folder 1, then it should return me the size of these two files plus these two files. So whatever the size, all these 4 elements, that should return me as a sum by this folder 1. And if I'm asking for the root directory file size, then whatever files inside whatever folder, it should sum all those files together and then return me the size in KB format, right? That is what our requirement. Let us see how we can implement this using our composite design part. So there are four elements. right? One is component, lib, composite, and a client, right? Let us create all those elements. Let me add a project. This is our project name. Let me make this as startup project, right? So first of all, you need to create the I component. So in this case, what I'm going to do, I'm creating an interface, and this interface is going to provide some functionality, which is going to be common for both leaf object as well as composite object, right? Let me copy the code, right? Okay, so here you can see it is you can create an abstract class or you can also create an interface, right? I'm going with the interface, right? In this case, if you want to create an interface, then this is also possible. In interface, you have not you cannot declare this a constructor, right? Then what you need to do inside, if you are going for interface, this constructor should be commented here, and it should be inside the child classes. So see, I'm declaring this interface, right? So you can go with any one. Here you need to remove these things, right? So you can go with like this, but what I'm going in the previous example, I have shown you the use of interface. Now I'm going to show you the use of abstract class, how you can use the abstract classes. See, basically, if you are creating one interface or abstract class, right, no issue. If you are creating abstract class, means you have the flexibility to provide some kind of implementation which is going to be same for the child classes. And in this case, this file system item, this is nothing but one constructor which is going to initialize the component name. Even if you are not interested, you can also move this to the child class, right? You can also move this to the child class. Let us move this to the child class. In the child class, we are going to initialize the component name. But if you want, then you can also initialize that here, right? So this is my component interface. And if you see this component interface having one property, which is going to be available to both leaf component as components. And this is one method which is going to be override in the child classes, right? So let me create the leaf component. So what is the component name I'm going to provide here? You can see file system item. And the leaf component, what I'm going to do, I'm creating a class file with the name file item. And then I'm creating the class file, and then I'm copy pasting things, right? So inside this class, what are the things I'm going to do? So file bytes. So whenever I'm creating a class, right? Whenever I'm creating the class, so name equals to, so in the file system, this is the name property. Let me make this as get and set. Name equals to name. You can initialize both here if you are not interested for this one. But if you are interested for this one, then what you need to do, you need to remove this one, right? And you need to pass the name property to the parent class base constructor. How you can do this? By using the base keyword. And what parameter value you need to pass? You need to pass the name parameter value, right? So both options are available. Whichever options you like, you can go with that options, right? So this file bytes, this is one property. And you can see this is the file item, this is the constructor. While you are creating an instance of this leaf object, you need to pass at least two things. What are the things? One is name of the file, and another thing is what is the size of the file. And then this name you are passing to the parent class constructor, because the name property is defined inside the parent class, right? Inside the parent class, the name property is defined. You can see this is initialized. And this file bytes means this is a variable which is declared inside this class, and you are just initializing that variable by using the second parameter, right? So then what we need to do, if you remember, we are having one abstract method, and as abstract method, you need to override that method in the child class, right? We are overriding. So what we are doing here, now, whenever we are storing the file, it is going to store the file in the form of bytes. Then what we need to do, so whatever the file size in bytes, we need to convert that file into KB. KB means we need to divide that number, right? That size with 124. And here I'm using the decimal divide method. This is a static method, right? If you go to the definition, then you will see this is static method available in divide class. It is expecting two parameters, decimal D1 and decimal D2, right? So you can see this is the first parameter and this is the second parameter. And it will do the division operation, and whatever the value, that is going to be written by this method, and it is nothing but in the form of a KB. So this is our leaf object. Once the leaf object is created, next we need to create the composite object. And in this in the case of composite object, it is going to be our directory. So you can give any name. You can also give composite.cs like the previous example. And here I'm giving the name as a directory, but it is up to you only. So whatever name you need to decide, that you can also give it, but the meaning should be related to your application. It should not be like that you can give it any name, random. If you are giving random name, then it is not going to give you any compilation error, any runtime error, but it doesn't make any sense, right? It should always be the naming convention should always be related to the project what you are developing. This is the reason why we are saying this is object oriented programming. So like this file item class, which is inherited from this file system item abstract class, this directory class is also inherited from this file system item class. And here, the point that you need to remember, it is also taking one name, but in this case, it is not taking the size, because we do not need to find the size of a folder. Whenever I'm asking the size of a folder or size of a composite object, it should give me the size of the actual leaf object, whatever stored inside that composite object. So you can say, here you can say file size is required, but in this case, only file name is required, the composite file name. And we are passing that to the base class constructor. And this is the property which is going to hold the child elements, right, of a composite elements. Like always, you should have the flexibility to add element to, you should have the flexibility to remove element from a composite component. So for that purpose, we are creating this add component method, and we are creating this remove component method. So add component means it is going to add the new item what you are passing to this add component method inside this children's list of children variable, right? Remove means it is going to remove that component from this variable, and then here you can see get size. But what the thing is that in this case, it is returning the actual size of the file, right? Actual size of the leaf object. But here we are not interested for the actual size, but rather we are interested for all the child components actual size. See, in this case, this children might be content 5 element, might be content 2 child leaf object, right? Whatever the leaf object, right? Just on each leaf object, call this get size in KB method. So I'm using this linQ sum method, and to the linQ sub method on each individual object. Individual object means you can see this file item object, right? There is a method called get size in KB, and that method I'm calling here, right? Using the lambda expression. This get in size in KB method. Suppose suppose the component object contain 2 children, then this method will be called twice. Each time whatever value it written, it is going to sum those values, and then it is going to return the summation, right? If this is not clear at the moment, right, so we can simplify these things. Sorry, not this one. For age, what is the collection name? This is children item. So what you can do is you can create one variable integer total equals to 0. Then what you need to do, total equals to total plus item dot get size in KB. So this is nothing but what is decimal to integer. So let me create this as a decimal, right? So here item means this is the leaf object, right? So if you are getting confused, so leaf object. So you can also do. So whatever I'm doing here, right? Creating a variable, then I'm calling each, I'm getting each object from the children's complex type, right? You can say it's a list type. So accessing each element of this collection, and on each element I'm calling this get size in game method. Whatever it return, I'm storing that value. I'm adding that value with this total value, right? So these things can be simplified by using a single statement, and that statement is nothing but here also you need to write this one. Return, you have to return this ones, right? So this 6 statements, whatever I'm doing here, can be simplified using a single statement using the lint queue, right? So this is the directory or composite component. Once this is done, then we need to use these components inside the program class, which is nothing but our client class, right? So you can say, let me open this one first. So how many child components or leaf components? 1, 2, 3, 4, 5, 6. Let's create 6 leaf objects. So you can see 3, 4, 5, and 6 leaf object. While creating the file item class instance, you can see it is expecting name and size of the file. So what I'm giving here, I'm giving so the name and file size. You can see while creating the leaf object, I'm giving the file name and what is the size, and this value what I'm passing here, it is in the form of it is in the form of a bytes only. So once you create the leaf object, then we need to create the child object. So in our previous example, we started from a button to top. Now I'm going to start from top to bottom. Top to bottom means I will create the root directory folder 1, folder 2, subfolder like this, right? So root directory, and this is my root directory. The name I have given root directory. You can, if you don't want this one, right? As per our example, you can give this as a root, right? Inside this root directory, how many subfolders are there? Folder 1 and folder 2. Let me create folder 1, folder 2. Let me add this 2 folder inside this root directory. Root directory, inside this root directory, I'm in the composite object class. There is a method called add component. So you can call this add component and this. If you don't want this, right, you can also call the remove. Suppose I'm creating another directory, right? So suppose directory 3. Right, so you can also add the directory. So here you can also add a root directory 3, right? Even you can also remove the directory, right? So both functionality we have given. You can add component, you can remove component, right? Like this. So I'm not going to show you this remove component because this is not required, because it is not going to show anything. So we have added the root directory, and inside this root directory, I have added folder 1 and the folder 2. This is going to be folder, right? So we have added folder 1 and the folder 2. Now, inside folder 1, what we need to do? We need to add 2 text file, one text file, one video file, and another subfolder, right? So inside folder 1, I'm adding my book, my video, right? So you can see I'm adding my book and my video child components, right? And then what we need, I need to add this subfolder, right? So what I'm doing, I'm creating subfolder 1. Inside subfolder 1, I'm adding 2 elements, my music and my resume. I'm adding my music, my resume. Once these things are done, then this subfolder will also be part of this folder 1 directory. So what I'm doing, inside folder 1, I'm adding this subfolder elements. Then what I'm going to do, guys, give me 1 minute. Right, and you can see inside this folder 2, I have to add my software and my document, and that is what I'm doing here, folder 2, and inside folder 2, my software and my document. And already this folder 2, folder 1, they have already added inside the root directory, right? So any sequence you can follow, right? So basically what is our intention? Our intention is to make a tree structure, right? And here you can see composite object, root directory dot get in size, folder 1 size, folder 2 size, subfolder 1 size, individual object. You can also call the get size method in the same manner, right? Now run the application and you will get the output as expected. Clear, guys?
Clear. Thank you.
Yeah, it's clear, sir.
Okay. So guys, one task is for you, right? So basically, I have implemented this one, but I'm not going to explain this example. It is a task to you. Already, I have provided the documentation on my website. I will share the link, but you just try to do this one by yourself. Suppose this is your company hierarchy. You are working, if you are working for any organization, then you know this is the organization. Inside this organization, there are a different department: IT department, HR department, sales department, right? So many different security admin department, right? Infosec department, many different department, and in each department there are multiple employees working. So what is our requirement? We need to get the So basically, what is our requirement? We need to get the employee name and salary details of employee name and salary details. So what is, if I'm creating an Anurag, it's a leaf object, right? If I'm creating an instance of this leaf object and calling the get details method, then it should show me the details of Anurag and its salary. If I'm creating an instance of IT department and calling the get details method, then it should display me the name of these 3 employees along with their salaries. And same in the case of a HR department. But if I'm calling the get company method, if I'm creating an instance of a company composite object and calling the get details method, then it should display me the salary of a Pranay, Rohit, Anurag, Priyanka, and Sambit, all departments. This is what I need to represent. So basically in the output, what I want like this: all employees of the company, name Pranay salary, name Rohit salary, name Anurag salary, name and salary, name and salary. And then I'm going to display total salary of the company is this one. IT department, name Pranay, Rohit, Anurag, total salary of IT department is this one. HR department, employees, name Priyanka and Sambit, whatever name, total salary of HR department. Then I need to call the salary of employee Pranay, name Pranay, salary this, salary of employee Anurag, name Anurag, salary this. So basically you need to create an application which should display the data like this. This is a task to you guys. You have to do this by yourself. I have given 2 examples, and this is also related to that particular example, but this is what I want in the output. Clear?
Okay.
Right, but before looking at the documentation, what I'm going to share, right? Already the example implementation is there, but you don't look at the code first, right? First of all, you need to try this, you need to solve this, and once you are solving this, then you need to compare your code with my code. If you are facing any difficulty, then you can look at the code. Otherwise, first you try by yourself and try to solve this problem. Clear? And here you can see this is component leaf composite client. The UML diagram is going to be same, right? These 4 components will come into the picture. Clear, guys? All about composite design pattern, what is, how to implement, when to use, what are the different components, what is the use of each component, how you are using those child components inside the parent or composite components, how you are going to add element to the composite component, how you are going to remove element from the composite component, what exactly happening if I'm calling the composite component, right? So why we are saying this is, what is the main objective? Main objective is we can treat both individual and the composite object in a same manner, right? For as a client, both are going to be same for us. This is all about your composite design pattern. Next, what we are going to discuss, proxy design pattern, right? So proxy design pattern, I know you guys are very much aware about this proxy design pattern, because in my college days, if some of my friends are not coming to the college, then we are giving the proxy on behalf of our friend, right? So this is the same thing. Proxy means on behalf of someone, right? That person is not available, but on behalf of that person, we are doing the things, right? So according to Gango for design pattern, right? Gango for definition, proxy design pattern provides a surrogate. Surrogate means act on behalf of another, or you can say placeholder for another object to control access to it. What it means, It means the proxy design pattern allows us to create a class that represents the functionality of other classes. The proxy interface will with anything, right? That proxy interface, what we are going to do, it can do different types of work like network connection, large object in memory, a file, some other resources that are expensive or impossible to duplicate, right? For example, you can see this is the real object. The client will not use this real object. The client will use this proxy object. The proxy object will internally use the real object in many different manner. Many different manner means, see, this proxy design pattern is suppose it's used for different conditions. Condition means, suppose this real object and you don't want to provide access this real object to all the clients, all the employees, right? There is a shared folder, and that shared folder you can say you can only give access to the manager and CEO of the company, not to the developer. Then you can create this proxy object, and this proxy object will check, will do all the necessary validations, whether the employee having this role or not. If this role, then only access to this real object, else just return from here saying that you do not have what you can say access, or you do not have permission to do some kind of operation on this there. Second example is that suppose suppose one so while this real object, this instance creation is very heavy. Instance creation means while we are creating the real object instance, it is going to load one 200 KB file from the text, right? Then that creating instance means loading the file, which is going to be an expensive operation. Once it load the file, then we can call the display method to show the to display the image. That means that object creation is heavy. And if the client is as the client is requesting to display the object again and again, means you need to create the object first again and again. If you are creating the object again and again, then what it means? It means it is going to take more and more time. So what this proxy design pattern will do is, if the request is coming for the first time, it is going to create the real object and store that real object in the cache. And then it will call the display object method of this real object method, which is going to display the object. When the second request will come, then it is not going to create the instance of the real object. Rather, it will fetch the real object instance from the cache, and then it will call the real object. It will call the display method. That means in this case, we can improve the application performance. The previous example, we are providing security, means we are protecting the real object. In this case, we are providing some kind of flexibility so that we can improve the application performance, right? That means what? Now we can say that proxy is the object, right? This is nothing but object which is called by the client. The client is not going to call the real object, rather the client is going to call the proxy object, and this proxy object will internally give access to the real object behind the scene. So proxy means in place of, on behalf of. That means proxy design pattern means a class represents the functionality of another class. This is the real object. This real object functionality is provided by this class to the client. The client is going to use the proxy object instead of the real object. This proxy object will decide what to do with the real object, whether I need to forward this request to the real object or not, whether I need to create an instance of this real object or not. So all this kind of complicated logic you can write here, right? So let us understand the above definition, right? Please have a look at the following diagram for a better understanding. As you can see in the following image, when the client wants to consume some of the methods of a real object, then the client needs to go via the proxy object. That means the client will call the method of the proxy object, and the proxy object will be responsible to call the method of the actual object or the real object. So this is nothing but your proxy design pattern. Let us understand this proxy design pattern with some real time example. Say, let's assume we are living in 1970. So let's assume we are living in 1970 or 1980 or 1990. In that time, right, if you want to withdraw some money, then what you need to do? Suppose, look at this image. This is State Bank of India. It is one of the bank in India, and there is a person called Anurag. Anurag having one account in this bank. Then Anurag wants to withdraw some money. Then what Anurag needs to do? He needs to travel to the bank. He needs to get the form, that withdraw form. He needs to fill up the form. Then he needs to stand in the queue
And when his turn comes, then he need to hand over the form which is filled by him and the passbook to the employee of the bank. Then the employee of the bank will do the verification whether the data what he fill up in the form is correct or not, whether the amount what he wants to withdraw is available in his bank account or not. And if everything is goes fine, right, then then the bank employee will return the required amount or the withdraw amount to the Anurag. This is what happening in the earlier 90s, right? 1980, 1990. But now what happens? But now the same person, Anurag, wants to withdraw money. But how many guys you are going to the bank to withdraw money, and how many guys you are going to the ATM? 90% people are going to the ATM for withdraw purpose. For some other, suppose you are withdrawing some high amount, then you can go to the bank, or for some other functionality, you are going to the bank. But most of the time, if you are trying to withdraw the money, then you will go to the ATM, right? So in previous case, the person has to visit to the bank where his account is. But now the person will not visit to the bank, he will visit to the nearest ATM. And again, this ATM of any bank, it doesn't matter whether the ATM should be of a state bank. Any bank ATM, you can withdraw the money. So now the person will come to the ATM. And once he comes to the ATM, he will insert his debit card, he will enter the PIN. And once he enter the debit card and enter his PIN, then this ATM will communicate with the bank. The bank means the actual logic is written inside the bank. The bank will verify whether his ATM card is valid or not, whether the ATM PIN number he entered is a valid one for that particular ATM card or not. Once the validation is done, then he will give one message that validation is successful. Then he will display the the dashboard, right? Dashboard means where he can select what he wants to do. Suppose second time he do some withdraw functionality, right? We select the withdraw option, enter some amount, and when he press the enter button, then again this information will go to the bank. The bank will verify whether the amount the client, the person wants to withdraw is available in his bank or not. If available, then he will return that yes, the ATM is the amount, withdraw amount is valid, and he will deduct the amount from his bank, and from ATM he will get the money. So in this case, this ATM is nothing but the proxy, and this bank is nothing but the real object, and the client is using the proxy. Internally, the proxy is doing the real operation, right, in the bank only. That means here the proxy object, right, it is nothing but your interface which the client is going to consume, right? So this is, I think, one of the best example of proxy design pattern. Second thing, what is the, if someone asks you why we need to use the proxy design pattern, you have to tell two things: improve performance by using the proxy server, filtering request by using the proxy server. How you can improve the performance and how you can filter the request? See, this is the real server, this is the proxy server, and this is the client. The client, as we already discussed, going to use the proxy server. Proxy server internally going to use the real server. So one of the important advantages of using proxy design pattern is improving the performance. See, inside this real server, you need to create an object of this real server to consume the method. And that object creation, right, is, let's assume that that object creation is a time-consuming process. That means if the request is coming 100 times, means you need to create 100 real server object. If creating 100 real server object means it will take more time. So what this proxy server will do is, it is not going to create the real server object each and every time a request comes. So what he will do, he will create the real server object, and it will store that real server object in the cache for some amount of time. It is not for lifelong, for some amount of time. Let's assume 30 minutes or 1 hour or 1 day. Right, and within that particular time period, if the client requests for the same operation or same object once more, then what he needs to do, he is not going to create the real server object. Rather, he will get the real server object from the cache, and he will consume the call the method directly. So in this way, it can improve the performance of your application. Second one is filtering request. As we told you, suppose inside this real server, some confidential data is there within one folder. Some confidential folder is there. And what is your requirement? You need to protect those data. It should not be accessed by anyone. Only the manager or the CEO of the company can have only access to that particular folder. Then you can filter the request by using this proxy server. Whenever the request comes, you need to write the logic. You need to check what is the role of the employee, whether the employee is a CEO, whether the employee is a manager, whether the employee is a developer, or anything else, right? If the employee is not a manager, not a CEO, then I'm not going to forward this request to the real server to do the operation. So from here only, it will return back and it will show you that you do not have access to access that particular confidential folder. That means if 100 request is coming, then it might be possible that 50 is from developer and 50 is from manager and CEO. Then it will filter 50 requests, and those 50 requests will go to the real server, which employ those requests which employee role is CEO and the manager, and those filter 50 requests which develop whose role is a developer, they are simply written from the proxy. So that means it is also used for filtering the request. So these are the two use cases you can say where you can use the proxy design pattern. I will show you two examples, right? I will show you how you can improve the performance, and I will show you another example how you can filter the request, right? Let me first.
Sir, question.
Yes.
When
Yes.
production time, the proxy server down, so how client gonna get data?
Right, so production time, see, whenever we are creating, so we should have the flexibility, right? So if you know exactly what term we are saying, right? PRODUCT, production server, right? So in real-time application, right? If you are working for a very big company or MNC company, there is another server, right, which is identical to the proxy server. This production server, right? This production server, and you are having one more server that is the backup production server, right?
Okay.
So, so you need to do the setting in such a way. These are identical. Means what? The server is different. That IP address, what you are saying, storing here, the IP address is completely different. Two different IP addresses, right? And in usually the code, right? The deployment, whatever the DLL, all those things, right? Everything is going to be same. The database is both are pointing to the same. Everything is same, right? Only difference is that this is the usually used. And whenever this server is down, you need to make sure that backup server will come into the picture, right?
Okay.
The setting is there. Similarly, if the proxy server is down, you should have another. See, for us it's a proxy server, but for internally for the system, it's only a server, right? And you should have the backup of that proxy server. If one server is down, the alternative server will come into the picture and will process the request as it is, right? So this is the ideal. So if you are working for any big MNC company, then you should know, you will see these kind of things, right? For each server, there
How
is a
many
backup.
production
Only
servers available?
only one is there, not more than one. If both are down, then you need to then your IT team or admin team will do some R&D. It's not possible that both are going to be down, because see, if this is storing in some different address like this, right, then the IP address of the server is going to be different one. And if both are down, then we cannot do anything else,
Yeah.
right?
Okay.
Right. If this is down, then this will come into the picture as a what you can say backup, right? If both are down, then you need to take care why it is down, and you need to identify where the issue is and how you can resolve the issue. Clear, guys?
Yeah.
Okay. So let us first discuss that protection. Protection means how you can filter the request, right? And then I will show you how you can improve the application using. See, this is our shared computer, right? This shared computer having one shared folder where we are putting some confidential information. And this is the folder proxy, means this is the proxy server, right? Now, say if it is an employee means the manager, CEO, developer, everyone is one employee of the company. And what this folder proxy will do is he will restrict if the employee who are trying to access this shared folder on this shared computer, if that employee having the role manager and CEO, they can only give access to do the read-write operation on the shared folder. If the employee role is not manager or CO, if the role is developer, then simply from this only we need to give restrict. Restrict means we need to give some information that you do not have permission to access this shared folder. And from there only we need to return the, we need to return. And if the role is CO and manager, then we can access, then we can go to the real object, right? And there you can, and there the developer, there the manager and CEO can do the read-write operation. This is what we need to implement by using the proxy design pattern. Let me first implement this, then I will show you the class diagram. Close all documents. This is my proxy design pattern. Let me create this as startup project. Okay, so this is not related to what I can say any component. Rather, you can say this is the list of employees who are going to access the shared folder. That list of employees means we need to store the employee information. Employee information like what is the username, password, and the role, right? So those information, or to store those information, we are going to use this class called employee. See, username, password, and role. And here you can see we are initializing these three. Right, what is the username, password? In general, the user will tell these two things, and from your database you will come to know what is the role of that particular user. But here I'm not interacting with any database, so I'm also going to hard code this role. But in real time, you will get the role from the database. Right, then we need to create the subject interface. This subject interface means it is going to one interface, and this interface is going to provide some kind of operations which are going to be implemented by the real object and the proxy object, right? Suppose in this case, what I'm doing, I'm going to create the interface with one method, right? So perform read-write operation. So this method is going to be implemented. This is the subject interface. So this is the term which is related to the design pattern, right? But technically, if you say this is one interface, and this interface providing one method called perform RW operations, read-write operations, and this method is going to be implemented by the real object as well as the proxy object. See how it is going to implement, right? So let me create the real subject, and in this case, the real subject is shared folder. So what I'm going to do, I'm creating a class file with the name shared folder. This is going to be your real subject, right? Real subject means this is the real object, the real server where the actual operation is going to be performed. Say this class is implementing the I shared folder, providing implementation, and here we are allowing the user to do the read-write operations, right? And then what we need to do, we need to create the proxy server, right? Proxy server means the proxy object. And this proxy object is going to be used by the client. And this proxy object will filter whether to forward the request to the real server or not. That filtering the request is going to be handled by this proxy server. Let me copy the code and then I will explain you what I'm doing inside this one, right? See, this is the employee, right? Employee means the employee who is going to access that employee information you need to provide while creating the instance of this class, right? Suppose why? Because if someone want to access this read-write operation method, then that should be an employee, and that employee information you need to pass while creating the instance of this shared folder of this proxy server. Again, this is the reference variable, which is nothing but pointing to this actual object, right? So this reference variable, what we are created here, it is going to be initialized and it is going to point to this actual server, right? And how it is going to use, let us see. First of all, this is going to be initialized by using the constructor, but this is not going to initialized using the constructor. This is depending upon the situation, right? What situation? Whenever the client calls this perform read-write operation, then to call this method, he needs to create an instance of this class. While creating the instance, he needs to pass the employee information who wants to access this method. Then here and that employee we are initializing with this employee private variable. So here we need to check the role. If the role is CO or If the role is manager, then only we need to initialize this one. And we need to initialize that variable, and then we need to share that share folder proxy mails calls to the real folder, right? That means here the shared server or the proxy server making a request to the real server. How? By calling this method, right? And this method means this is the instance of our actual server. If the role is not CO and if the role is not manager, then simply we are saying shared folder proxy says you do not have permission to access this folder, right? So this is the use of shared server. This is the use of a proxy server, and this is our real server. Now the client is going to use this server. The client is not going to use this shared server, right? Now let me copy the code and put it inside the main method. This is nothing but your client code. And in client code, you can see what I'm doing. I'm creating client passing employee with role developer to folder proxy. So I'm creating one employee where the role is a developer, and I'm creating the shared folder proxy means proxy server instance. And while creating the instance, you need to pass the employee object because the constructor expecting one employee object of type employee, right? So here I'm passing this emp1 to this shared folder proxy. And when I'm calling this perform read operation, then this employee one, what is role? Role is developer. So in this case, it will check what is the role. Either the role is C or no. The role is manager, no. That means it is not C or manager. Let me execute the else block. Else block means it will not call the actual, it will not create the actual real server object, and it will not forward the request to the real server. Simply it is returning this one. Now the second time you can see I'm creating another object and the role is manager. So now you can see I'm passing that emp2 to this shared folder proxy and calling this perform read operation on the proxy server. So this method will call. Here it will check the role. Role is manager. Yes, it is satisfying because we are using the logical or. Or means either one of the condition is true. Yes, this condition is true. Means create the actual object instance and call this method. So that's why in this way you can see by using the proxy design pattern, we can filter the request, right? For the first object, right? For the first employee, you will see you do not have permission issue. For the second object, you can see it is accessing the real object, right? So shared folder proxy says you do not have permission to access this folder. Client passing employee with role manager to folder proxy, right? Then you can see it is performing the read operation on the shared folder. Any question from anyone? Guys?
No questions.
Okay.
No questions, sir.
So now if you want to see the class diagram, then this is the interface. This interface providing some perform actions. This is the actual class, which is implementing this perform action method. This is the proxy class. This proxy class having a reference to the real subject, right? If you see this proxy class, it is having a reference to the real subject. The reference is nothing but this one, right? And also it is implementing the perform action, and the client is going to use this perform action, and the perform action will filter the request whether this this perform action will decide whether I need to forward this request to the real subject or not. So these are the four components. Interface one, and this is nothing but in our example it's I shared folder. And then you have real subject. Real subject means the real object, in this case shared folder. And this is the proxy class. Proxy class means this is nothing but your proxy class, and this program class is nothing but our main method. Clear? So see, in this example, whatever we discussed, this is nothing but virtual proxy. Virtual proxy means control access to sensitive master objects, right? That means what? It will verify whether I need to forward the request to the actual object or not. And the next what we are discussing is virtual proxy. This is nothing but if the object creation is very expensive, then instead of creating the object again and again, this virtual proxy will create the object once and reuse that object for some point of time, some period of time. So we'll discuss this one, right? And if someone asks you why we need to use proxy design pattern, then you need to tell two things. What are the things? You need to tell if you want to improve the performance using the proxy server. If you want to filter the request using proxy server, then you need to use proxy design pattern. Clear, guys?
Clear.
Okay. So the example what we discussed, it is for filtering the request using proxy server, right? Because if you say out of 2 requests, 1 request is forward to the actual, I mean to the real server, and 1 request it just filtered out and it just written from there, right? This is one kind of example using proxy design pattern. Now I'm going to show you another example, that is the virtual proxy. That is how you can improve the performance of an application, right? Suppose this is my real, or you can say this is my real server, and inside the server there is a file with size 200 MB, right? And the client want to display that image on the screen. Then what the client needs to do? The client without proxy server, I'm talking about first without proxy. Think that the system B is not available. This is system A, which is nothing but your real server. Once the client wants to consume this 200 MB, wants to display the size of this file, then what he needs to do? He needs to create an object of this class, and he needs to load this image from the disk to the application, and then he needs to display the image. So guys, remember that these steps we need to do again and again. The client wants to display this tiger image. The client, suppose the client calling for the first time, again we need to create the object, we need to load the image, and then we need to display the image by calling the display method. The client is saying again that I need to load the image, then the same steps we need to follow again and again. So the number of times the client requests to load the tiger image, to display the tiger image, we need to follow these 2 steps. Steps 1, create the class instance, load the image from the disk to your in-memory, and from your in-memory, then you need to call this display image method to display the image. So this step 1, what you can see here, right, creating the real image object and loading the image from the disk, it is taking more time. It is a heavy operation. That means creating this object is expensive. Then what I can do here is I can introduce this virtual proxy. What now, as I introduce this virtual proxy, now the client is not going to consume the real server. Instead, it is going to use the proxy server. The proxy server will do what? This proxy server having this real image object, right? So it is also having a reference to this real image. Then before creating the instance, it will check whether the instance is created or not. It is some kind of a singleton you can consider, whether the real image instance is created or not. If it is not created, if the client requests for the first time, then it will create the real image and load the image from the disk to in memory. And then it will call the display image method, which will return the image, and that image it is going to return to the client. But before returning the image to the client, what he will do, right? So once this step 1, once it is creating the real image object and load the image from the disk, what this the virtual proxy will do is it will cache that image for some time. It will cache that image for some time, and then it will call this display image method, which is going to display the image. The client sends the request again. Now, before doing the step 1, it will check the cache, whether the real image object is created or not. In the previous request, only step 1 executed. So in this case, it will find that yes, the real image is available in the proxy. So I'm not going to execute step 1. Rather, it will get the object from the proxy. And once it gets the object, then it simply calls the step 2, which is going to display the image. That means in this way, we can improve the performance of the application, right? That expensive object creation is going to be reduced by using this virtual proxy. Let us see how we can implement. This is the example. This is the class diagram. We'll create one interface, image. This is going to be subject that is going to provide the method which is going to be implemented by the real subject and proxy class. The real subject is going to load the real image, and it is going to having the display image method. This proxy class is also having this proxy image, having a reference variable to this real subject, and then this display image method. The client is going to use this proxy class. Let us understand this diagram. If still not clear to use, once we see the diagram, once we implement the example, then you will understand this very clearly. Right. So let me create a new project to my solution. Add new project. So I'm giving this project as virtual proxy design pattern. right? First, we need to create the I subject. I subject means I image, the subject interface. Create a class file. Okay, let me make this a startup project. Create a class file with the name I image, which is going to provide the functionality, which is going to be implemented by both the real subject and the proxy class. So in this case, that functionality is nothing but a display image. Right, so display image. This is the subject interface. This interface is going to be implemented by both the real subject and the proxy. So create a class file with the name real image. This is the real server. You can say the real class. So create a class file real image.cs and then copy paste the code. So here the point that you need to understand is the object creation is very expensive, right? So you can see this is the file name, which you want, which I'm initializing this the class constructor, right? And here I'm having one method load image from the disk. And if you see, while this constructor is executing, it is calling this method load image from disk. And in this case, it is going to load the image which of size 2 MB from the disk to in memory. Right, once and this steps is going to be expensive one. It is going to take some time to processing, right? And then you can see this is the display image method, which is going to be this one. This display image method is implemented here. So here you can see it is simply displaying the image, right? So this is the file name. We are initializing that file using the class constructor. And once we initialize the file, then we are loading that file from the disk, right? Loading the image from the disk. Once we load, the object creation is done. That means this method is nothing but as part of your object creation process. This method is going to take some time, right? Take some time means you can see what I can use. So I'm going to delay the execution for 5 seconds, right? So from seconds, I'm going to delay the execution for 5 seconds, right? So you can consider like this. And then once the object is created, we can call this method. It is going to display the image. So this is the actual object implementation. Next, what we need to do, we need to create the proxy object. So in this case, what I'm going to do, I'm giving the class name as proxy image.cs. Proxy image.cs. Then what I'm doing, I'm just copy pasting this code. This is very simple and very straightforward. What you can say, like real image, which is implementing the I image, providing implementation for display image. This real image, this proxy image also implementing this one, right? But here you need to see one thing, right? So real image, this is the proxy image. While creating the instance, you need to pass the file name, which is going to store inside this variable. And from the client is going to create an instance. This instance creation is not that heavy, right? It is just simply needs to pass the file name. And as part of this display image method, we are checking whether this real image equals to null or not. If it is not equals to null, right, then we are just calling the display image method, right? And if it is equals to null, then we are creating the real image instance here. That means only one time this instance is going to be created. This is not a thread shape, and we know how to make the thread shape. That is what I'm not going to explain now, right? But now you can see only one object is going to be created, and when this real image variable value is null. If it is not null, means what? This object is not, this statement is not going to be executed. First time request come, this object value is null. It is going to create an instance of a real image, and while creating the instance, this load image method is going to be executed, and it will delay the execution for 5 seconds, right? And then it is going to display the image. Second time we are calling this display image method. When the second time request comes, this object is all, this real image variable is already initialized. Then no need to execute this step. If this step is not executing, that means this constructor is not executing, means what? This method is not executing. This method is not executing means the execution is not delayed by 5 seconds. right? Now you can directly call this display image method as the instance is already created, means the image is already loaded from the disk to in memory and simply going to display the image, right? Now what I'm going to do, I'm going to show you how the client is going to consume this. So from the client, what we need to do, we need to create the proxy image and image one calling display image for the first time, second time, third time. So when it is called the display image for the first time, it is going to delay the execution by 5 seconds. So what I can see, loading image. So what I can see, okay, loading image processing. Image completed. Loading image processing and loading image completed. That means you will see these things in the E1, right? So these things you will see when you call the display image method for the first time. For the second time, you are loading the same tiger image, no need to load again. Third time, no need to load again, right? So again, you are creating the lion image, another image you want to load. Again, when you call the display image, it is going to load the thing. And for first time, it is going to take some time. From the second time onwards, it is not going to take the time, right? So I'm calling this for the 3 times, right? Third time, right? So now let me run the application and show you the output. See, first time loading image processing, tiger image. After 5 times, for the second, third time, it is not taking time. And for the second image, it is taking some time, and then it is giving the result immediately. So in this case, so in this way, you can improve the application by using the proxy design pattern. Clear, guys?
Clear.
Any question from anyone?
No, sir.
Okay, fine. So the last design pattern, what belongs to this category is flyweight design pattern. Let me explain this flyweight design pattern. This is not that important, but if you know this, good. But I never used this flyweight design pattern in any of my application, right? Because the such requirements never come. So what is flyweight design pattern? The flyweight design pattern is used when there is a need to create a large number of objects of almost similar type. A large number of objects means it will consume a large amount of memory, and the flyweight design pattern provides a solution for reducing the load on memory by sharing objects. This design pattern is basically used to reduce the number of objects created. Reduce the number of object creation. Let me highlight this point. As the number of objects created is reduced, it will reduce the memory footprint. Memory issue you will not face. And as it is memory issue will not face, then it will improve the overall performance of the application. So these are the things you will get. That means the flyweight design pattern tried to reduce the already existing similar kind of objects by storing them in the cache and creating a new object where no matching object is found. Okay. So let me explain this with one example. What exactly the meaning? Suppose you are having one image. Suppose you are doing some campaigning and you are one of the member of any political party in the election time. You want to do some kind of campaigning. For that purpose, you want some kind of a poster, right? And one image, one PDF file or one image you have, and you want to create 1,000 copies of that poster, or you can say 1,000 copies of that image, right? So 1,000 copies. So you have 2 options. What are the options? So option one. So you need to do printout of 100 copies of the 100 copies of this image. 1,000 printout. You can you can take the image, give that image to the you can say to the person who wants to do the printout, and you say, yeah, I just need 100 printout. And in this case, if you want printout is 2 USD, one printout is 2 USD, then total how much money you want to pay, you need to pay 1000 into what you can say 2 equals to 2000 USD for 100 printout. Yes or no? Guys, if you are having one image, you want 100 printout of that image, 100 copies of that image, you are having one option. You can give that image to the shopkeeper and tell, I want 100 printout, and then he will give you 100 printout. If the one printout cost is 2 USD, then for 100 printout you have to pay 200 USD. This is option 1. Option 2, what you need to do? Take one printout, take one printout, and once you get the printout, then what you need to do? Make 99 xeroxes. And in this case, let's assume one printout is USD, and Xerox is generally Xerox is less price as compared to printout, and one Xerox is 1 USD. 1 USD. Then how much total he needs to consume in this case? So in this case, 1 into 2, 1 into 999 plus 1 into 2. So total how much? 1001. So which one is less? Which approach is best?
Option 2.
Option 2. This option 2, what I'm showing here, it is nothing but your flyweight design pattern. So in that case, if you want to create an instance 100 times, if you have one class and you want to create 100 instances, right? Then in that case, create one instance and use that reused instance for 999 times. Let us understand this with one example. Suppose you are having one circle object, right? You are having this circle object, and now you want to create 90,000 green color, 90,000 blue color circle object, 80,000 black color, and 70,000 orange color circle objects. If you see, the shape of the circle object is same. What is only difference? The color is going to be different. So in that case, instead of creating 90,000, 1987, what is the total, whatever may be the number, instead of creating that much number of objects, right? What you can do is you can create only one object, store that object in the case. When you need 90,000 green color circle objects, then get the object which is stored in the cache and then apply the color. So in this case, instead of creating this much number of objects, we have to create only one object, store that object in the cache, and whenever the and how much and what type of a color you require, then you can get those from the you can apply them by getting the object from the cache. So as per Flyweight design pattern, we can improve the performance by creating the circle object only one time and reusing that circle object many times to create different types of color. Suppose you want to create a 90,000 circle object with the green color, then what you can do is, instead of creating new circle object 90,000 times, right, and filling them with the green color, so what you can do, you can get the circle object from the cache and then fill the object with the green color. In the same way, if you want to create an 80,000 black color, you can also follow the same thing. Get the object from the cache and fill the object with the black color. So in that way, we can avoid creating the object again and again. And in this way, the Flyweight design pattern is going to implement, is going to provide what I can say, improve the application performance by using Flyweight design pattern. But when you are using the Flyweight design pattern, you need to understand two steps. So whenever we are creating an object, right, there are the two steps: intrinsic and extrinsic. What is intrinsic and what is extrinsic? Now, intrinsic states are the things that are constants and stored in memory. On the other end, extrinsics are the states, right, which are not constant and whose value will be calculated on the fly, and hence you cannot store them in the memory. So in our example, the shape of the color object is going to be same, but the color is going to be vary. So the color is going to be vary. So we can, as the shape of the circle object is going to be same and it's a constant. So we can store the circle object in the cache. But sometimes you can see the circle object with the green color, blue color, black color, red color, different color. That means the color is going to be vary on the fly. So the color is what I can say extrinsic, and you cannot store the object with color in the cache. So circle object without color you can store in the cache, but circle object with color you cannot store on the cache because the color is going to be vary. So whichever is fixed, whichever is constant, you can store that thing in the cache, and whichever is not fixed, whose value will be calculated on the fly, that you cannot store on the cache. So if constant, it is intrinsic. If not constant, this is extrinsic, right? So let us understand this with one real-time example, right? You guys must have known the Angry Birds video game. Suppose, let's say, in the Angry Birds video game, we want to create 50,000 Angry Birds with red color. And imagine if we are going to create new 50,000 Angry Birds and fill them with red color, then how much memory it will occupy. And as it is going to occupy more and more memory, then definitely you will get memory footprint issues. So to avoid this memory footprint issues or to avoid this memory problem, what we can do here is we can create only one Angry Bird without any color, store that Angry Bird in the cache, and whenever we need any new Angry Bird object, we just need to get the Angry Bird from the object and then fill the Angry Bird with whatever color you want. Suppose you want red color, you can fill the Angry Bird with red color. You want green color, you can fill the Angry Bird with green color. So in this way, we are not going to create 50,000 Angry Birds. Instead, we will create only one Angry Bird and we will reuse that Angry Bird 50,000 times by creating them with different color. So in this example, the shape of the Angry Bird is constant. So we can store it in memory. The shape of the Angry Bird is as constant as we can store that in memory, right? So we can say that is intrinsic state of the Angry Bird. The color of the Angry Bird is intrinsic state, extrinsic state. Why? Because the color is not constant, right? One time the color is black, one time the color is red, one time the color is green, and as the color is calculated on the fly, that means the color is not constant. As it is not constant, so we cannot store that in the memory. As it is not constant, as we cannot store that in the memory, so it belongs to extrinsic state. So the point that you need to remember, intrinsic means constant and can be stored in memory, that is in the cache. Extrinsic means the value is not constant, value is going to be calculated on the fly and we cannot store that in the cache. So this is the difference between extrinsic state and intrinsic state. So let us implement this with one example. I will come to this diagram later. First, let me explain this example. So what is our requirement? We need to create this many objects. We need to create red color circle 50,000 times, green color circle 40,000 times, blue color circle 60, orange color circle 70, black color circle 20 times. That means total 24,000 circle objects we need to create with different colors, right? Let us see how we can implement using Flyweight design pattern. Let me close all these things, close all documents, create a new project. Okay, Flyweight design pattern, make this as the startup project, right? So first we need to create the Flyweight interface. This is the interface, right, which is going to provide some of the intrinsic feature, right? Create an interface. Intrinsic feature means the things which can stored in the cache, right? Let me create the isep.cs class file. So this is going to be isep.cs, and then let me copy the components. Copy the code, right? So you can see this is the Flyweight interface. This is an interface that defines the member of the Flyweight object. That means draw. Draw means you can draw the circle object, right? So color is different things, but color, right? Setting the color, drawing the object, two things. Drawing the object means creating the circle object. Creating the circle object means its shape is going to be fixed. Color is not fixed. Color is going to be vary on the fly. So we cannot put color inside this class. So whichever things is constant, whichever things you can store on the cache, those things we can put inside this interface, inside this Flyweight interface. So in this case, it is nothing but our draw method, which is going to create the circle object. Then the second thing is that we need to create the concrete Flyweight. That means what? See, concrete Flyweight means you can create different types of colors, different types of shapes, like circle, rectangle, triangle, anything, right? So we are going to give this. We are going to create the circle object. I'm going to create one method circle. If you want to create a rectangle, you can create a class called rectangle. For triangle, you can create another class called a triangle. So this is nothing but your concrete Flyweight. Concrete Flyweight means Flyweight is this is the Flyweight. It's nothing but interface. Concrete Flyweight means the class which is going to implement the Flyweight interface, and in this case circle. So you can say this is my draw method, which I have defined in the ISEP interface, and here you can see there is a property called color, and also I'm having some different properties: x coordinate, y coordinate, and radius. The shape is going to be fixed. As the shape is going to be fixed, as we are initializing them, right, with the fixed values, that means the shape of the circle object is going to be fixed. And whenever we call this draw method, right, then it is going to draw. So color should not be there. If color is should not be, yeah, let's put it as it, so that you will see whenever I'm drawing the color should not be there, right? X coordinate value it will display, y coordinate value it will display, radius value it will display. And then I'm having one method, right, that set color. This method is going to be set the color of the object. That means the object is going to be of any color, but while we are drawing the object, it is having the fixed length, right? I will show you how you can use this, right? How you can use this. I mean, how you can use this means you need to create an instance and call the draw method, which will draw the object. Once the object is created, we can store that object in the cache, right? Once the object is, once the object is, so in this case, while creating the instance, by default, these variables are going to be created, right? X coordinate, Y coordinate, radius, right? With some fixed values. No constructor means what? The default constructor will come into the picture, and that default constructor is going to, what it will do, it will create these properties with these fixed values, and those fixed values means we can store them in the cache, and then we can set the color, and we can display what are the what are the things available of that particular object by using this draw, right? Now Flyweight factor, right? Flyweight factor means this is going to handle whether the object needs to be created or not, right? And it is also going to store the object in the cache. So those things is going to be handled by this Flyweight factor. And if you remember, the factory design pattern means what? It is going to take some parameter and return some of the instance which the client required, right? Let me explain these things first. So this is the Flyweight factory. This is the factory class used to create a concrete object of the concrete Flyweight type. So concrete Flyweight type object it is going to create. So this is one dictionary I have created, string. The key is going to be string. The value is going to be ISEP. ISEP means the Flyweight interface. So Flyweight interface means the class which implement this ISEP. It's nothing but this circle class. That circle class object I can store here, right? And get shape. This is the method, right, which is going to return the shape, right? And here you can see it is taking the shape type. And here, if the shape type is circle, right, then what I'm going to do, I'm going to check whether this circle object, right, this is nothing but, you can consider the key. This key is available inside this dictionary or not. If the dictionary, if this key is available inside this dictionary, then whatever the value associated with that key is nothing but one of the circle object, fetch that circle object, right? And that circle object is going to store inside this shape variable. And if the key were, if first time I'm calling the get shape method, that means this key is not available inside this dictionary, then this else part is going to be executed. What it will do, it will create the circle object. Only one circle object is going to be created. Then I'm adding that circle object, right, where I'm going to add inside the cache. So this dictionary is going to act like a cache for us. And we are adding, and then we are saying that creating circle object without any color in shape. right? So we have created the circle object without any color and then returning that shape, right? So once you have done this, that's it, right? Once the client get the object, then what the client is going to do? The client is going to set the color, and the client is going to, what you can say, display the data, right? So in this case, you can see, so this is circle factory, it's a class, this is a get shape, this is a static method. So you can call the shape factory static method, and this is the circle. Circle means you can say this is the object that what you are passing. I want to, this is nothing but the key circle. I want to get the circle. So first of all, I need to create circle object with red color, 5,000 circle object with red color. Then what you can see, suppose 50,000 means you have to write like this, 50,000 circle object you want to create. Yes, I want to create 50,000 circle object. That means I need to use one kind of looping. Inside this looping, I'm calling this get shape method, and this get shape method is going to return me the circle object, right? And then I'm setting the color, and then I'm printing the data whether it is showing the red color or not. The same thing I'm going to do for the green color, I'm going to do for the blue color, I'm going to do for the orange color, I'm going to do the for the black color. So instead of 50,000, what I'm going to do, I'm going to give 3, because 50,000 data I cannot show in my console. So when the request is for the first time for the circle object, so this time it is going to get the data from the object. It will first time this value will be not available in the dictionary. So this part is going to be execute, means the object is going to be created. Once the object is created, then it is going to add the object in the cache, and then it is saying that creating circle object without any color, and then we are setting the color, and then we are calling the drop. Then we are setting the green color. So in this case, same circle object. So again, you will see the shape is going to be same. If the shape is going to be same, then what will happen? It is not going to create the object again and again. And here, even though we are setting the color as green, it is still using the same circle object. So what it means you will see that this piece of code is going to be executed only once. It is not going to execute more than once. And in the circle constructor, there is no constructor. For that purpose, what I'm going to show you is, okay, so to make you understand, the circle object is created only one time. So what I'm going to do, I'm creating the circle constructor, parameterless constructor, and here I'm saying circle object is created. So this will specify how many times the circle object is created. If it is executed more than one, if more than one circle instance is created, means the statement is going to be executed more than one time, right? Let me run the application. So in this case, it will create one object and it will reuse that object any number of times, like the way it will take one printout and then it will make the xeroxes. So in the same way, it will create the object, the circle object only once, and then it will reuse that. See, red color circles, circle object is created. So circle object is created means the constructor is executed. So circle object is created, the constructor is executed. First, let me see how many times this statement is printed. Circle object is created only one time. You can see this statement is never printed more than one. What it means? It means it gives us the clarity that this object is going to be created only once, right? And then you can see it is reusing that object, right? It is reusing that object to create 3 red color circle, right? It is reusing that object to create 3 green color, right? So why it is showing green and green 2 times, I don't know, orange and black. So there is some issue. So what is the issue? Issue is in our code. You have to give this as a blue, right? Because we have set this as blue. Right. So in this way, we can use Flyweight design pattern, which is going to reduce the number of times the object created. If the shape of the object is going to be same, then you can use Flyweight design pattern and reuse that object as many times as you want. Now, if you go to the class diagram, right? Then you will understand this very clear. Flyweight, this is the interface which is providing the operations. These operations is going to be implemented by the concrete flyweight, and this is our flyweight factory, right? So the client is going to use the factory. Oh, the diagram is wrong one. So the client is not going to use this concrete flyweight. It is going to use the flyweight factory, right? So here you can see we are using the flyweight factory, and that flyweight factory is going to return the object. So this diagram is wrong. In this case, it is not pointing to this concrete flyweight. It should point to this one, right? I will update this diagram and I will share the documents, right? And this flyweight factory having some method based on the key. The client will pass call this method by passing the key, and this method is going to return the appropriate flyweight instance via this flyweight interface, right? So in this case, if you go, it is going to return the actual flyweight instance via this circle, right? So here, instead of what I can say, circle, you cannot, you can use ishape also here. But if you use ishape, then you cannot call this set color method, because this set color method is not available inside this ishape, right? This is the reason why I'm converting that object to appropriate type. Clear, guys?
Yes, sir.
Okay, that's it. With this, our this pattern is completed, right? So we have completed the structural design pattern. We have completed the creational design pattern. The remaining is behavioral design pattern, which we will discuss from Monday, from Tuesday. Monday, I'm having some work. From Tuesday, we are going to start behavioral design pattern. Any question from anyone?
No, sir. So next class is on Monday, sir.
No, not Monday. It's on Tuesday. Monday, I'm having some work. I'm going outside. Tuesday.
Okay.
So in the next week, I'm going to complete the design patterns. Totally.
Okay, sir.
Yeah. Thank you, guys.